Okay, welcome to this session on forecasting and predictive analytics. Okay, today's first day. We'll have introduction about the topic. Okay, so what do you mean by forecasting? What is forecasting? Any idea?
I'm hearing it for the first time, sir.
You're hearing for the first time. Okay, so if I ask you, will it rain tomorrow or not? If I ask you, will it rain tomorrow?
Maybe or may not.
Right? So what do you say? If I ask you one answer,
Sorry?
if I ask you one answer, what do you think? Will it rain or not?
No, sir.
No? Okay. So this is forecasting. Okay. This is called forecasting. We are talking about something that will happen in future. Okay. So in terms of business, they would want to know how much sales they would make. Right? Let's say you start a business. You start a small shop. How big the shop should be? How many people should you employ? Right? If you can forecast that you are going to make a lot of sale, then probably you can hire 10 people.
Yes.
If you think that you cannot hire or you cannot increase your sales, then you will not hire more people. So forecasting is important in every business decisions that we make. Okay. So now again, now let me tell you, I asked this question other day to Sahil. I'll ask you to both of you. If I buy 10 pens or 100 pens, let's say, I bought 100 pens and the cost price is 50 rupees. And I sold at 100 rupees. How much profit I'll make?
50 rupees.
So I have bought 100 pens. So total, how much profit I'm going to make total?
Sir, 100 pens, sir?
Yes.
How much rupees you are selling, sir?
100 rupees. I bought for 50, selling for 100. And there are 100
We have
pens.
50 rupees profit. Total.
Yes, 50 rupees profit, but I have 100 pens.
Yes.
So how much profit will I make total?
5,000.
How much?
5,000.
Everybody agrees? Okay. So
Yes,
how
sir.
much profit you said? 5,000.
Yes,
Right?
sir.
Is this forecasting? Is this predicting?
Yes.
Okay. So no, this is not forecasting. This is not predicting. Okay. See here, it is a straightforward problem. Okay. We know exactly how much you are going to make.
Yes.
This is not forecasting.
Or predicting.
Okay. This is not predicting. We call this as, this problem, what I just told you, is called as deterministic model.
Yes.
Deterministic. I'll give you notes, okay? But if you want, you can write it down. This is called deterministic model. Deterministic model means where you can use formula and get some value. So to find profit, what do you need to know? You need to know the profit per unit.
Yes, sir.
So you need to know two variables here. One, the profit per unit, profit per pen, and then second thing is total number of pens. So how many variables we have here? Three variables we have. One is total profit.
Yes, sir.
Correct? Total profit is one variable which we want, and then we have cost per pen,
Yes.
right? Or profit per pen. You can say selling price minus cost price, or profit per pen and total number of pens. So we have three variables. Okay. So this is an example of what we call as trivariate or multivariate. Univariate, bivariate, and then anything more than two we call it multivariate. Univariate means only one variable will be there. Bivariate means two variables will be there. Multivariate means more than two variables. So in this case, we call this is a three variable problem, okay, or multivariate problem, okay, and this is deterministic model. we are able to find the profit exactly. There is nothing less or more.
Yes.
There is no chance of error, right? Perfect. So it's called deterministic model. When you talk about forecasting and predictive analytics, it is not deterministic model. They are what we call as probabilistic model. Probabilistic. Probability is involved. Okay. Probabilistic model. Okay. Deterministic model is where you're able to determine the exact answer.
Yes.
But when you talk about forecasting, if you talk about your syllabus 403, it is all about probabilistic models. Okay, different chapters talks about different models. Okay, first chapter we talk about regression. Okay, so the example that earlier I asked, right? Will it rain? Now you can be wrong also. It can rain tomorrow, isn't it? You can be wrong also, but you feel that there's more probability of not raining, right? That's why you said it will not rain. If you had felt that there is no probability is more for raining, so you would have said it will rain.
Yes.
So in your mind, you're calculating the probability 50-50. Okay, but what is little more than 50? So you feel that not raining is more than 50, maybe 60% or 70% or 80% or 90%, whatever. So in your mind, you are calculating the probability. So this is what we call as deterministic model, sorry, probabilistic model. In probabilistic model, there will be some error. Okay, there will be some error. So this is first point you have to note it down. Okay? Number of variables, deterministic model and probabilistic model. Forecasting is all about probabilistic model where we are trying to calculate the probability, and whichever has the highest probability, that is the answer. Okay, we cannot find exact answer. Okay, point one. Now point number two, which you have to all understand, is the different types of data. Okay, you would have done it in 203. Different types of data. What are different types of data? Numerical,
Alphabetical.
text,
Character.
categorical,
Categorical.
time series,
Time series.
time
Numerical.
series,
Categorical.
right? What is categorical values?
Yes, sir. Yes, no, male, female.
Correct. Where the answer is given in the set, right?
Yes.
You talk about grade, you will get A, B, C, D or E grade, right?
Yes.
So you will get only one out of these five, male, female, only one out of these two, right? Yes, no, only one out of these two values. So where the total value is limited and you can get any value from that set
Yes.
or from the categories. So from category, we get categorical values. Okay. So all the variables that we spoke about three variables, right? So can you tell me what type of these variables are? What was the first variable we discussed? We discussed about profit, total profit. So what kind of variable is that?
Numerical.
Numeric variable, right? You get any now. Numeric variable means you can get any value. You can get 0.5, 0.71, 1.9, 1.92825, whatever. So those are called numeric values. Okay. Cost price is what type of value?
Yes, sir. Categorical.
Cost price.
Cost price. Numerical.
Yes, cost price is also numerical. Number of units?
Number of units. Numerical.
Numerical. Here, all three are numerical type. Okay. So now you understand the data type, you understand the variables, isn't it? One more concept you have to understand before we get into details is that when you perform such calculations, there is one variable on the left hand side. We say something equal to and then the formula, right? So what is the formula that we used? We used TP, total profit, right? TP equal to, okay, let me write it down on the board. Let me share my screen. Okay, so the formula that we wrote is TP, okay, total profit equal to selling price, right? 100 minus cost price, right? 50 into number of units, N, number of pens. This is the formula that we used. Yes, no?
The selling price equals to selling price minus cost price, sir.
Total profit.
Acha.
Total
Equals
profit equal to selling price minus cost price
Cost
into
price.
number of pens. Now N.
Okay.
So total, this is the total profit formula. Yes. Okay. So
Okay,
what
sir.
are we trying to find here? We are trying to find, okay, so this is deterministic, not probabilistic model. Okay. We are trying to find this TP. Okay. Generally, we represent this with Y value, or we call this as predictor. This is what we are trying to predict. Okay. This is what we are trying to predict, predictor. Okay. Now this Y is also called as dependent variable.
Dependent.
Dependent.
Yes.
Because the value of profit is dependent on these values. Selling price, cost price, and are all independent variables. You can put anything, right? It can be anything. It's not dependent. Okay, but total profit. So generally we write dependent variable or predictor on left side. On the right side we have independent, or we call them features on the right
We
side.
can't hear your voice, sir.
Can't hear my voice?
Yes.
So this is, let me repeat it. This is dependent variable or predictor variable. Yes.
Yes.
And this is independent variable. Okay. So the model, see, everything is probabilistic model. Are you understood? Even in the probabilistic model, we look at the value or type of the data on the Y of Y. What is that we're trying to predict? We are trying to predict profit. We're trying to predict sales. So what is the data type here? Type is numeric. Okay, so if you are predicting, if you are forecasting a numeric variable, we use regression concept. Did you get it?
Yes, sir.
Regression is a concept when you are trying to predict a numerical variable. Profit is numerical. Sales price is numerical. Price of the house. You bought a land today and you want to know what would be the price of land after 1 year, 5 years, 10 years. Yeah, those are all numerical values. So you're trying to predict numerical values there, right? So those are examples of numerical, predicting numerical, forecasting numerical values, and we have to use regression concept.
Yes.
Okay. Now let's say you are running your shop and you see someone coming to your store. You want to predict whether that person will buy the product from your shop or not.
No.
Will buy from your shop or not. So we are trying to predict yes, no. Okay. Yes buy or no buy. Correct. So this is an example of predicting categorical values. When you are trying to predict categorical values, we have to use the concept of classification.
Yes, classification.
Did you get it?
Yes, sir.
So regression and classification are probabilistic models where in regression we are trying to predict the outcome variable which is of numerical type. We always look at y, not x can be anything. You can have multiple variables, isn't it? It can be your numerical, categorical, it can be anything. But on your y value is only one. We always are trying to predict only one value, okay? So if y is numerical, we use regression model. If y is categorical, we use classification model. So regression is our chapter 1 and classification is our chapter 2. Okay. So the whole chapter is how do you predict a numerical value? We are trying to predict. In chapter 2, we will also try to predict, but we will try to predict the classification values, which is more of a categorical values that we will predict. Okay. Okay. So any questions so far? You understood what we are doing?
Yes, sir.
Okay. Now, we also call these things as machine learning. What do we call these as?
Machine.
What is human learning?
Yes, sir.
Human learning. What is human learning?
Human learning, we are learning now, like you are teaching for us.
Right? So you are learning in a classroom, we call it as human learning, isn't it? Yes. So as a human being, we are learning. So in probabilistic model, and the reason why we are doing this course, okay, when you talk about predictive analytics or forecasting, why we are learning this course is that these concepts are very, very old. These are more than 100 years old concept. Regression is, I don't know, maybe even 200 years old concept. Okay, but we are learning now these things because we want computer to calculate these things for us and give us the answer. Okay, we want computer to calculate and give us the answer. So we are making machine learn these concepts. Yes. We are making machine learn regression and classification concept. Okay, so machine learning can be of different type. Okay, when supervised learning. Supervised learning is when you are learning from a teacher. Yes. You have someone who will tell you to do this or not to do this. Okay. So in the classroom setup where I am here and telling you about some topic, this is the example of supervised learning. Okay. So in supervised learning, see what is the difference between you and me? Why am I a teacher here? Because I have little more knowledge than you on this topic only. Since I have little more knowledge, okay, on this topic, so I'm a teacher here, I'm telling you. So what does that mean? That means I have more data, I have experience, I have experience of learning this thing before and using it. I have learned this before you and I have used it. That's why today I'm here to teach you, right? So in supervised learning, you need old data. Okay, so let's see another example. If I ask you, okay, that what do you think the price of land will be if I buy a land in Miapur, let's say. Miapur is where I stay. So what will be the price of land in Miapur, where I stay? So can you guess? If you don't know anything about Miapur, can you predict? Can you forecast?
No, sir.
No, you can't.
Yeah.
Right? You need to know about real estate industry. You need to know about history of Miapur. Okay, what are the things based on which land price is decided? Hospital, nearby, distance. Farther it is from hospital, lower will be the price rise. Nearer to hospital, more price rise. Okay, factories. Okay, all those things.
Infrastructure facilities.
Yes, right. So infrastructure, facilities, all these will decide. So you should also know what happens when facilities come. If facilities come, the price will go up or go down?
Up.
Up. So somebody has to teach you those things, right? You know, that's what you're saying. But if you had not known about it, you would not have said. So in supervised learning, we need old data, okay? And in old data, we need both what was the, so like you can say that I have seen in ABC area, okay, and the price was X, and when they announced airport, price became 100X. So that is a knowledge that you already have. So you need some kind of old data where you know both X and Y. What is X and what is Y? What is X, what is Y?
Sir?
What is X and what is Y?
Sir, variable, sir.
Sorry?
Sir?
I'm asking you guys, what is X, what is Y?
The dependent variables, independent variables, sir.
Which is dependent, which is independent?
Sir?
Which is dependent?
Y is dependent, sir.
Yes, Y is dependent. So in supervised learning, you will have old data, okay, and you will have, okay, independent
X1,
variables,
X2, X3,
okay, and you will have
Xn.
Y, dependent variable. So you need to have old data, okay? You need to know the connection between X and Y. Then you can predict for any future problems, okay? Then second type of learning is unsupervised learning.
Yes, sir.
In unsupervised learning, we don't have a teacher. See, in classroom, you probably spend what, 3-4 hours, right? But more time you spend outside. You watch movies, you see your parents, you see people around you, you see what's happening in TV series, movies, newspaper, and from there we learn. So nobody's telling you, okay? You are learning on your own. This is called unsupervised learning. Okay, so you do not have X and Y value. You might have only X. You do not have Y value. So you are, can you predict? Can you learn? Answer is yes, you can predict. Okay, so this is called supervised learning, where you have old data, you have the knowledge. Based on that, you are trying to predict the new values. So unsupervised learning is where you don't have old values, nobody has told you, but based on the environment you are learning. Okay, so supervised learning examples are regression and classification. These are examples of supervised learning.
Yes.
Okay, the third chapter that you have, which is clustering, isn't it? Clustering is an example of unsupervised learning. Okay, so let me give you one more example. Let's say I dump, all different types of fruits: apple, banana, cherry, mango. Okay, let's say I dump all these fruits in a house. Okay, and I put a 4 basket. Okay, I put 4 basket. I have labeled it. I have said apple, banana, cherry, mango. So I have dumped all the fruits. Okay, there are many more fruits. Like we have only 4 types of fruits, but there are many more. Count of fruits. And I have put 4 basket. Now I want you to put all bananas in banana basket, mango in mango basket, apple in apple basket, cherry in cherry basket. Can you do that?
Yes, sir.
You can do that, right?
Yes.
So here you know the fruit name, you have the basket, you are putting in the respective basket. So this is an example of supervised learning where somebody has already told you what is banana. Somebody has already told you what is apple, right? So you know apple, banana, and you are putting it in the basket. Fine. Now, second example is, okay, I got 4 different fruits from Africa, which let's say we have never seen. Okay, you have never seen, you don't know the names. And same thing I do, I dump in the house. And I ask you to put it in the basket. Can you do that? You don't know the names. Can you put that in the basket?
Yes.
Yes, no?
Yes.
How will you do that?
Sir, can you say once again, sir?
Okay, so see, first thing understood, right? I put apple, banana, cherry, mango. I'm asking you to put it in the basket. You did it.
Yes, sir.
Second exercise, I've got some fruit from Africa. Okay,
Yes.
you don't know the names, I don't know the names.
Yes.
We have never seen it. 4 fruits, and I'm asking you to put them in the baskets, individual basket.
Yes.
Can you do it?
No, sir.
Can't you do it?
No, no.
You can do it, isn't it?
Sir,
See.
but we don't know, no, sir, that's fruit or what.
Yes, but see, all the eggs will be of same size, color, shape.
Yes, sir.
Some banana, okay, for a minute, you think that you don't know the names of banana,
Yes.
or cherry, or mango, or apple. Let's say that you are seeing for the first time. You have not seen before, you are seeing for the first time. You don't know the name, you have not seen apple before. Can't you pick all the apple and put it in one basket?
Yes, sir, we can.
Yes?
Yes.
How? Based on the characteristics.
Colors.
Based on the characteristics,
Yes.
right? Shape, size, color. So based on that, we can put them in a basket, right? So even if you don't know the names, we can do that. But the problem here is you cannot label, you cannot say this is mango, this is apple, or this is cherry, or this is banana. You cannot say that. But you can put them together in one basket.
Yes.
Even if you don't know the names of the fruit, because based on the characteristics. So supervised learning, that is your regression and classification, are called as labeled data. Because data is labeled, we know what it is. We know it is yes, no. But in case of clustering, you can perform prediction or forecasting, but you don't know, okay, what is the name of the fruit. So you cannot put them in different baskets. You can put them in different basket, but you cannot name them. That's what I'm trying to say, right? So this is an example of clustering, and clustering, this is what we do. There we do not have Y. Okay, you'll have only X. There's no supervisor to teach you what is Y, but still you'll be able to predict, okay, or forecast the Y value. Okay, and in clustering, we only forecast based on the type. Okay, we do not label as yes, no, or male, female, or north, south, east, west, right? We forecast in ABCD category, ABCD. We do not know the name, so we say 1, 2, 3, 4, ABCD. Okay, whatever name you can put, you can put. So this is, okay, clustering, and this is what we'll do in chapter 3. Yes? Yes, guys?
Yes, sir.
Okay. So this is the notes, okay? This is the book. Soon book will be in the market. This you will get it, okay? So whatever I've said, you can read through this PDF. So this is talking about supervised, unsupervised, same example. See, apple, banana, grapes, and cherry.
Sir,
Okay.
you send this PDF to us, sir.
Yes, yes. And add me, create a group, no? Add me in a group. So any question,
Sir, once you,
sorry?
sir, once you can say your number, sir.
94.
Sir, once.
Yeah, yeah.
94
904
904
674
674
64.
64.
Yes.
Sir, once. 94
Yes.
904
Yes.
674
Yes.
64.
Yes.
Okay, sir.
Okay. So you can add me and I'll send all the information there. Okay. So this same thing, whatever we discussed, right? Supervised and supervised, you can still predict based on the color, shape, the size, right? And you will be able to differentiate between apple, banana, cherry, grapes. Okay. Our time is done.
Yes, sir.
Okay. I'll take. No. I mean, the class was just after that. Okay. Yes, yes. Okay. So we'll just discuss this. I'll take 2 minutes and we will wrap up. Okay. Okay. So see, these are different types of machine learning algorithms. Okay. And this is what we are doing in our class. Okay.
Yes,
so
sir.
third type of learning, which I did not say and which is not in topic, is called reinforcement learning.
Reinforcement learning.
Reinforcement learning. Reinforcement learning is based on what we call as feedback system. You perform something, you get positive feedback, you do it more. You get negative feedback, you don't do it. Like, for example, when you play a chess, right? When you play a chess, you think of a move. Okay, if I move this here, okay, what will happen? Okay, if you think if I move it here, then I will be in advantageous position. That means positive thing for you. Then you will play that move, right? But if you feel that no, if I do this, opponent will, will become in advantageous position, then you don't play. That's called feedback. So you think what will happen. Okay, there is no past data. See, in supervised learning, you have both X and Y from past. In unsupervised, you have only X, no Y. In reinforcement learning, you do not have any data. You are trying to predict what will happen if I do this. Positive thing, do it. Negative thing, don't do it. Right? When you're driving a bike, you don't jump the red signal. Why? Because police is there to fine you. So it's a negative thing. Oh, if I jump the red signal, I will have to pay the fine. So you don't do it. Okay, when police is not there, then we cross. Why? Because there is no one to fine. Right? So see, this is called reinforcement learning. Okay, so we plan, and this is not in topic. Okay, so we will not do this. We'll focus mainly on supervised and unsupervised. So unsupervised, supervised learning, and if you're talking about continuous target variable, your numerical values are continuous, we use regression. If you're predicting categorical value, we are doing classification. Okay, irrespective of target probably will be group. Okay, you don't have the target variable, you don't know the past data, what has happened. We do clustering. Association is again not in your syllabus. Okay, these things are not there. We have only regression, classification, and clustering. Okay, so example here is housing price prediction. What will happen to the house price? Right now you bought a house, what will happen to the price after 5 years? You're trying to predict. So that is an example of a regression algorithm. Then medical imaging. So when you do the x-rays, right? Doctors will look at the x-ray and will tell you there is a problem or no problem. So this is an example of category. Problem, disease or no disease, problem or no problem, right? So you have only two options there. So in x-ray, when they take x-ray, you are trying to predict if problem is there or not. That is example of categorical value. So we use classification. And there are different algorithms. That's what we will learn in our class. Okay, we'll talk about different algorithms. And the third one is called clustering. So customer segmentation. Okay, so See, you have these retail stores, right? Big Bazaar has so many stores. Lifestyle has so many stores. In Hyderabad, they have so many stores. Across the different cities in India, they have so many stores. How do they manage all the stores? If they have 1,000 stores, they will not manage each 1,000 store. And also, they will not send same product to all the stores. So when you go and see the stores, okay, a store in Banjara Hills will have different product than a store in Lakdi Ka Pul, than a store in Koti. The products that they will have, same company, will have different product based on the location, because depend upon the people that come, right? Some people go for buying cheaper cloth, so they will keep cheap clothes. Some people go and they buy brand expensive cloth. Banjara Hills, Jubilee Hills, they don't mind price, so there the store will keep expensive product. So they have to manage individual store, not okay same. They will not make same decision for all the stores. Okay, they will make individual decisions. Okay, point one. So what happens is, when they have 1,000 stores, how will they manage 1,000 stores differently? They need 1,000 people to do that. No. So what they do is, they create as segmentation. They call it as store clustering. They segment, they group. So instead of looking at all the 1,000 stores as one group, they will divide it into 10, 15 or 20 groups. Okay. So here, you don't need to know yes or no. Here, group A, B, C, D is also okay. This is an example of clustering, where you don't know, you will simply base the characteristics. Okay, what kind of people stay there? Okay, all businessmen are staying there. Businessmen staying in Jubilee Hills. Now, there's no other place in Hyderabad like that, but there could be one place in Guwahati, one place in Delhi, one place in, or maybe two places in Bombay. Okay, so what they will do, these similar stores, okay, they will say, okay, store number 101 Hyderabad, store number 205 Guwahati, 309, okay, 259, 269. These stores together, they form one group. We will call them group 1. So instead of managing 1,000, they don't want to manage one, because not all stores are same. They will not manage 1,000 because managing 1,000 stores are also difficult. Instead, they will manage 15, 20, 30, such number of stores, depending upon the characteristics. So now they are managing only 30. So decision that they make for one store, same decision they will take it to the other stores. Did you get it?
Yes, sir.
Okay. So yes. So we'll stop here today. Tomorrow we will meet and we will get into regression. Did you understand the concept, what you are expected in this subject?
Yes, yes.
Okay, it is probabilistic model. It is not as simple as doing 5 into 10, 50 kind of thing. We have to involve probability. There is an error factor. Forecasting is always wrong. Forecasting is always wrong. But still we need to do forecasting, because we need to be prepared. Why do we have to forecast? Why do we have to predict? Because if you don't forecast, then how will you make decisions tomorrow? If you are running a business, how many people should hire? How much of product should you bring into your store to sell? How many employees? Okay, how big should be your store? All those decisions you are making based on the different inputs that we're going to talk about, dependent and independent variables, and we will see how in detail we are doing regression. And then in regression, depending upon the, see, regression we are using depending upon the dependent factor. Dependent factor is number, it is regression. But how many factors are there in independent variable? If it is only one independent, so you have one dependent, one independent, we use bivariate. Chapter number 1 in unit 1, bivariate. Then if it is more than two or more than two, we use multivariate. Okay, so we will see in detail tomorrow. Is that okay?
Yes, sir.
Any question before we end?
No.
Do you understand everything?
Yes, sir.
Yes? Sure?
Yes, sir.
Okay, good. So what I'll do, I will share the recording also, so that you can watch it later.
Sir, we have added you in group.
Perfect. Thank you. Okay, we'll communicate through group. I'll share the link in the group. Okay. And
Thank
yes, any questions, any doubt, please let me know.
Thank you.
Thank you. Thank you so much. Have a good day, everyone. We'll see you tomorrow. Bye.